Rational roots. Sorry for yelling that. So rational roots, that means that maybe it might be something like 3/2. We could write it as a ratio. But what it's telling us is that we're not going to have just a nice value like 4 for most of these. And so as we're told to solve n squared plus 6n plus 7 equals 0 by graphing, we'll take a quick look at this and ask ourselves, well, what are the factors of 7 that would add up to 6? And since that's not happening, we're going to erase this work because we could do that in our head and think about where should we really start preparing our x, y chart. Now, even though this says n, I like to do this with x and y. Now, we could try -2 and so on, or we could be a little bit more considerate here. And so over to the side, let's write x is -b over 2a, which means it would be -6 over 2 times 1, or just -3. From that, we know that we're going to have symmetry in this graph around -3. So I'll write -3, -4, -5, giving me 2 terms walking backwards. And then walking forwards, I'll get -2 and -1. And hopefully, when this happens, we'll get what we need from this graph. And that's that whole decision-making process that I'm talking about that guides, how detailed do we need to be with these? So I will go ahead and encourage you to take a calculator and type this in with parentheses so that your equations in your calculator look like this. And if you were to type that in, you would find that you would get a value of 2. Then go back, and since it's still negative, you could just go in and insert or delete and replace the 5 with a 4 and hit return, and your value would be -1. Same deal for 3. Still is negative, and you would get -2. Now I'm doing this quickly, but I hope that you're trying this out on your own. We still are plugging in a negative value, so we're going to go and replace that with 2, where we would get -1. And then we'd plug in -1, and we would get 2. Now, you might have wanted to cut a corner and been like, well, I know it's going to be symmetric about here, but by doing it thoroughly, it sort of guarantees as close as possible that you're not going to make those errors. Now, looking between these values, we're seeing something happen. And I think supporting this with a graph will make it more clear. So here's my graph. And for this, I'm going all the way back to -5. 4, 3, 2, 1. And maybe I want to give myself the axis of symmetry where x is -3 to help out. I did that in red to show that it's sort of optional, but it's always a good thing to do. And so back at -3, I have -2. And then at -4, I have -1. And then at -2, I have -1. And I kind of like to go back and forth as I do these because it keeps me in check. Now, were we asked anything about the y-intercept? No. And because of that, we don't have to be crazy detailed in our graph moving forward. But what we were asked about was this next part. So if integral roots, so meaning integers, cannot be found, estimate. And I really want to focus on the word estimate. If we were told to find, then we would have to be exact. But since it says estimate, we can kind of just be in the right ballpark. So we're going to estimate the roots by stating the consecutive integers between which the roots lie. And so as I look at this root here, I can tell that one is between -2 and -1. And by looking at this root here, I can tell that another is between -5 and -4. And if I look between these values, I see that the graph went from being positive, which would be all of my values above the x-axis, to being negative, which would be all my values below. And that positive to negative switch tells me that this graph crossed the x-axis, which tells me I got roots. So here I would say the x-intercepts are between -5 and -4, -5 and -4, and -2 and -1. And here's a little tip. If you use that many ands, it's misleading. So you probably want to write the word and out so that it better separates what you're talking about, so that the and symbol is matching up the two that are back to back rather than and 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 and. So this would be more than enough detail to support our answer. I imagine that number 2 can be an OYO problem. And because of that, I'm not going to take the time to do this one. But do the whole x is -b over 2a thing to guide where you should make your table and pivot those points. And if you still feel somewhat unsure, you can go to Wolfram Alpha using a graphing tool or a fancy calculator using a graphing tool to better guide where you want to start. This will be the last problem we do in this third video of these notes. Soccer. If a goalie kicks a soccer ball with an upward velocity of 65 feet per second and his foot meets the ball 3 feet off the ground, this function represents the height of the ball, y, in feet after t seconds. How long is the ball in the air? So let's make sure that, if I get this picture drawn, and actually I won't make this red. Let's make this something you have to do. So here's the picture. I'm picturing somebody kicking a ball, but not just from any height. They're 3 feet off the ground. That was a little detail that they gave me. And I'm also told the upward velocity. Now that would not be this angle. It would actually be a velocity straight up in the air, since they're only focusing on the upward velocity. So that's 65 feet per second. Now looking around in this function, look for a v or something that represents velocity. There's nothing. The only variables are t and y. But the 65 does show up there. So what's going on there is that they've already plugged in that number to a more challenging equation than we have seen. So how long is the ball in the air? Well, we got to be able to figure this out somewhere. How? At this point in our picture, the ball is in the air. At this point in the picture, the ball is still in the air, still in the air, still in the air. It stops being on the air when the height of the ball is at 0. And since they're using y to represent height, this is meaning that we're going to have to plug 0 in here and figure things out. So there's our function with 0 substituted in there. So at this point, you might be thinking to yourself, well, maybe I can do x as -65 over 2 times -16. And let's see what happens. Well, we get something, that's going to be approximately, what, 2, roughly 2. So you could try different things around 2, 3, and 4, and 5. And really pay attention to patterns. But for something with such kind of outrageous numbers as this, it's going to be absolutely okay for you to get a graphing calculator out. So with that graphing calculator out, or Wolfram Alpha, see if you can answer the problem on your own. If not, see me, and we'll check it out together so that you can better focus on whether or not I made a nice smiley face, so that you can better focus on how to change those windows and those fields and get the extents and how to type in equations into graphing calculators. So this is the third set of notes going with 9.2. Hopefully this section goes well.